you. Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ms. Linda. We'll continue with the IB past paper exams, oscillation and waves. Now the question here we have red laser light is incident on a double slit. Separation is 0.35 millimeters. So this is small d separation between the two slits. A double slit interference pattern is observed on a screen 2.4 meter from the slit. So the distance D capital is 2.4 meter. The distance between successive maxima on the screen is 4.7 millimeter. Now here we have a fringe pattern. We have bright and then dark and then bright again and then dark. So the distance between two bright, the center of two bright fringes, this is S. So S is 4.7 millimeter. Calculate the wavelength lambda of the light. Now for double slit, the formula lambda divided by D, the distance between the two slits, will equal S, the distance between the two maxima, divided by capital D. Lambda, we don't have it. Small d is 0.35 millimeter times 10 to the power -3 will equal S is 4.7 times 10 to the power -3 millimeter divided by capital D 2.4. Cross multiplication and you will get lambda. So you multiply 0.35 times 10 to the power -3 times 4.7 millimeter. So lambda will equal 0.35 times 10 to the power -3 times 4.7 times 10 to the power -3 divided by 2.4. You will get 6.9 times 10 to the power -7 meter. Okay. Second part of the question, explain the change to the appearance of the interference pattern when the red light laser is replaced by one that emits green light. Now, if you remember from our study, if I use different color of light, lambda for red is lambda is greater than the wavelength of any other color. So for red, since lambda is greater, the distance between the fringes also will be wider. If I use green, the distance will start to decrease. If I use purple or blue, the distance also will decrease because lambda is less. So for red, lambda is greater than lambda of the green. So the distance between the fringes or the width of the fringes will be less, or the distance between the maximum, you see the distance here, the width of the central maximum or between the maximum will what? Will decrease. The formula lambda over D equal S divided by D. From the formula also we can conclude that if I increase the wavelength, I use red color instead of green, the separation or the width of the maximum, the distance between the maximum will also increase, and the opposite, vice versa. Okay. So here we say lambda of the green is less than lambda for the red, lambda over B, lambda over D, lambda over D equals S over capital D. If I decrease lambda, the distance between maximum will also decrease. So S for the green will be less than S for red color. One of the slits now is covered. Describe the appearance of the pattern on the screen. One of the slits is now covered, so instead of having one slit, instead of having double slit, we are going to have one slit. Okay. If we have one slit, you see the width of the center fringes is greater than the width of the secondary fringes, and if I'm using double slit, we'll have more maximum, okay, not only one, and the width also will be less. Of course, it will be double. The brightness or the intensity for double slit, if I increase the slit, the intensity will be increased, but we're talking about here the width of the fringes or the central maximum. The width of the central maximum will be twice the width of the secondary maximum or secondary fringes. Also, the brightness of the central maximum compared to the other maximum is brighter. Okay, second question today we're going to solve two questions. So we're done with this question. We'll go to the second one, which is question number 10 from your document. Here we have a student is investigating a method to measure the mass of a wooden block by timing the period of its oscillation on a spring. Describe the conditions required for a block for an object to perform simple harmonic motion. We have two conditions. The first, so if you have a block attached to a spring and you stretch this block certain distance x, or you compress it certain distance x, so there is also always a restoring force that try to restore the object to its equilibrium position. The direction of the restoring force is opposite to the direction of displacement. So we have F directly proportional with the displacement in the negative direction. And we know from Newton's second law, mass times acceleration, force equal mass times acceleration. Force is directly proportional with the acceleration. That means the acceleration is directly proportional as well with the displacement in the negative direction. Second part of the question B. 0.52 kilogram mass performs simple harmonic motion with a period of 0.86 seconds. So this is T capital, the period. When attached to a spring, a wooden block attached to the same spring oscillates with a period of 0.74 seconds. So if I call this T1, this will be T2. Calculate the mass of the wooden block. Calculate the mass of the wooden block. Here, the first mass, this one, I'm going to call this one M1, 0.52. So I need to find into second mass. If you remember the formula, T, the period, will equal 2 pi square root mass over the spring constant. I need the mass, okay? So if I square this equation, I should get T square equals 4 pi square M divided by K. I'm using the same spring. Okay, but I change only the mass. So this number is constant. 4 pi over K is constant. That means T square directly proportional with M. So I can write a formula, create a formula, T2 square divided by T1 square equals M2 over M1 because of this proportionality. Now T2 square, it's 0.74 second squared divided by 0.86 square equals M2 over M1 is 0.52. Now cross multiplication and you should get M2. So M2 will be 0.39 kilogram. Don't forget the unit. Yeah. Now next for high level physics. In carrying out the experiment, the student displaced the block horizontally. So here we have a displacement by 4.8 centimeters. So this we can call it x naught. 4.8 centi times 10 to the power negative 2 meter, or divided by 100. Division is the same as you multiply by a negative power. So divide by 100 or times 10 to the power negative 2. From the equilibrium position, determine the total energy in the oscillation of the wooden block. Now, total energy, the formula, half m velocity square. To find the velocity, v, it's omega times the displacement. How can we find the omega? Omega is 2 pi divided by the period. So V will equal 2 pi divided by the period, which is 0.74, times the displacement, which is 4.8 times 10 to the power negative 2. And this is equal 0.41 meter per second. Now the total energy, E total, half, mass of the block, 0.39, times the velocity, 0.41 squared. And you should get 0.032 joule. Okay, the last part, you have a second identical spring is placed in parallel. So you have, this is the first spring, second spring, you place them in parallel. Now, when you put the spring in parallel, you increase actually the spring constant. So if this spring K1, for example, and this is K2, if they have the same spring constant, I'm doubling the spring constant. So K effective will equal K1 plus K2. So the spring constant now is increased. Now remember the formula, T equals 2 pi square root M over K. If I increase the spring constant, the period will be decreased. This is from this relationship, is the inversely proportional. The oscillation, the time it takes to complete one oscillation will be slow. It will take more time to complete one oscillation. Now, suggest the question is how this change affects the fractional uncertainty. Now we need to write a formula from this one. So to write a formula, this is power. This I can write it as 2 pi m over k to the power half. So fractional uncertainty, when you have division or multiplication or power, the power you get it out, constant, you ignore the constant. So we have to write formula for fractional uncertainty. It's the uncertainty divided by the original equals half, get it out, open bracket, fractional uncertainty for the mass, delta M uncertainty divided by the original, plus always add for the to calculate the uncertainty, this propagation uncertainty, whether you have multiplication, division, always add, even subtraction, add. So plus fractional uncertainty in the spring constant divided by K. So here, if I increase the fractional uncertainty in the period, what will happen to the fractional uncertainty in the mass of the block also will be increased also.